This is the Chapter 8 test review. We're going to work the first couple of problems from each section. So first we're going to look at number 1, which says to simplify. When you simplify, you're going to factor the top and factor the bottom and then see what cancels. So for this problem, the top part has two terms, so I'm going to check and see what do these two terms have in common, and they're both divisible by x. So I'm going to take the x out, and when I divide that x out and put it in front, it's going to leave me with x plus 4. In the denominator I have 3 terms, so I'm going to see what multiplies to give me 24 and adds to give me negative 2. So 24 could be 6 times 4. And if I do negative 6 and positive 4, then it adds up to be negative 2. So once we have it simplified, or once we have it factored, we're going to simplify it by canceling anything from the top to the bottom that matches. So I have x plus 4, which cancels with x plus 4. So my solution is just x divided by x minus 6. This is question number 2. We're still going to be simplifying, so we're going to factor the top and the bottom. And in this problem, I have 3 terms. So I'm going to see what multiplies to give me 11 and adds to give me positive 10. So we're going to go with 11 and 1. So 11 times 1 will give me a negative 11. If I do positive 11 and negative 1, then that will add up to 10. In the denominator I have 3 terms, so I'm going to multiply, see what multiplies to be 8 and adds to be 7. So we're going to have 8 times 1, positive 8, and negative 1 would add up to be 7. So once it's factored, I'm just going to check to see what can I cancel. And I can cancel x minus 1 with x minus 1. And that's going to leave x plus 11 divided by x plus 8. And now we're going to skip number 3, so you need to do number 3 on your own. For problem number 4, now we're multiplying. Multiplying and simplifying are almost the exact same thing. The only difference is that now we have 2 numerators and 2 denominators. So in this problem, we usually would factor first, but this problem is already factored. So I can go ahead and immediately look for things that will cancel. So I can see x minus 3 cancels top and bottom. I have x plus 7 cancels top to bottom. I have x minus 1 cancels top to bottom. And I'm left with the x plus 4 and a 4 and a 2. So I'm going to cancel just a little bit more because the 2 and the 4 can be reduced. So I'm going to reduce the 2 to 1, and I'm going to reduce the 4 to a 2. So now the only thing left in my numerator is x plus 4 times 2. So I'm going to write 2 times x plus 4. The only thing left in my denominator is a 1, so I don't need it at all. And I can go ahead and distribute the 2 and get 2x plus 8. So that's what you do if it's already factored. You just have to cancel. For number 5, we are multiplying. This time we do have to factor first. So we're going to start with this numerator and see what multiplies to give me 21 and adds to give me negative 10. So I can multiply 7 times 3 to get 21. And if they're both negative, then they would add up to negative 10. In this denominator, I only have 2 terms. So first I would check to see if they have anything in common, and they don't, except for the fact that both of them are perfect squares. So since it's a perfect squares, this is going to be the difference of two squares. So I'm going to have x plus 2 and x minus 2 because 2, 1, here we go. Okay, so the other fraction is already factored, and I know that because there's not anything I could take out of x or 2 that would simplify it, and there's not anything I can take out of x or 7 that would simplify it. So now it's just one great big fraction, and anything in the numerator can cancel with anything in the denominator. So I'm going to cancel x minus 7 with x minus 7, and x minus 2 with x minus 2. So I'm left with x minus 3 over x plus 2, and that's my solution. All right, number 6 we skipped. That's a problem to work on your own. Number 7 is the first of the division problems. So when we divide, we're going to keep the first fraction as it is. Then we're going to change the division into multiplication. So we're going to keep the first one, change the sign, and then we're going to flip the second fraction. All right, so keep, change, and then flip. Once we've done that, then we're going to factor. So all of these have 3 terms. So on each of them, we're going to multiply what multiplies to the end number and adds to the middle number. So for the first one, what multiplies to be 12 and adds to be 8, I'm going to go with 6 and 2. For that denominator, what multiplies to give me 10 and adds to give me negative 7, well, 10 is going to be 5 times 2. And if I make them both negative, then they'll add up to negative 7. In the other fraction in the numerator, what multiplies to give me negative 6 that adds to give me positive 1? And that is a 1, by the way. Sometimes people think it's 0, but it really is a 1. So we're going to go with positive 3 and negative 2 because that will add up to 1. And then for that denominator, what multiplies to give me 24 and adds to give me 10? I'm going to go with x plus 6 and x plus 4. So the first thing we did was keep, change, flip. Then we factored it, and now all we have to do is cancel. So I see x plus 6 cancels with x plus 6. X minus 2 cancels with x minus 2. And that leaves us with x plus 2 times x plus 3 over x minus 5 times x plus 4. So my solution will just be x plus 2 times x plus 3 over x minus 5 times x plus 4. Number 8 is also a division problem. So we're going to keep, change, flip first. This problem is very similar to one of the problems on the 8.4 quiz. So keep the first fraction, change this to multiplication, flip the second fraction. And then now we're going to factor this. 9x squared is a single term, so it doesn't have to be factored at all. 3x minus 3 has 2 terms, so I'm going to see what do they have in common. They're both divisible by 3. And if I take the 3 out, it's going to leave me with x minus 1. Don't forget that 3 divided by 3 is going to leave you with a 1. You have to have that placeholder there. In the right numerator, 2x squared minus x, those are both divisible by x. This might be a problem here. And this denominator, 3x squared and 12x are both divisible by 3x, which leaves me with x minus 4. So, I think I see a bit of a problem, but we'll go ahead and deal with what we've got. We don't have any groupings that are going to cancel, but we do have free numbers that will. So, for example, this x could cancel with this x right there. And since I have 3 times 3 in the denominator, and 3 times 3 equals 9, I could cancel both of these 3's with this 9. And that leaves me with a pretty big answer. X squared times 2x minus 1 over x minus 1 times x minus 4. But we were at least able to simplify parts of it. All right, I'm going to skip number 9. That's for you to do on your own. 1. Number 10, we are adding. So when we add, we have to have a common denominator. In this problem, my denominators are both x plus 3, so we already have the common denominator. So we're going to keep the denominator, and all I have to do is add the numerator. So I have x minus 4 plus 3x plus 1. So if I combine my like terms, I'm going to have x plus 3x, which is 4x, and negative 4 plus positive 1, which is negative 3, and that's my solution. For number 11, we're still adding and subtracting, but this time we do not have common denominators. So the first thing I'm going to do is look for a least common denominator or a least common multiple. So I'm going to make myself a little note area over here. And my denominators right now are x minus 4 and x plus 2. And neither one of these are the same, so I have to use both of them in my new denominator. So my new denominator is going to be x minus 4 times x plus 2. Alright, then I'm going to compare. My old denominator on the left side was x minus 4. My new denominator is x minus 4 and x plus 2. So the x plus 2 is the new part. So that means I have to multiply my numerator, my 4, by x plus 2 also. On the right side, the old denominator was x plus 2. My new denominator is x plus 2 and x minus 4. So I've got to put x minus 4 in my numerator also. So now I have a common denominator and I can keep it, but I have to subtract my numerators. So I'm going to take this side minus this side. So as I go through this, I'm going to go ahead and distribute. So 4 times x and 4 times 2 is going to be 4x plus 8. Now, when I distribute the 3, notice that this is subtraction. So I'm going to distribute it as negative 3. It's minus 3, so we're going to have negative 3 times x, which is negative 3x. And I'm going to have negative 3 times negative 4, which is positive 12. So I've got my denominator. That's not going to change. And now all I'm going to do is combine like terms. So 4x minus 3x just gives me 1x. And positive 8 with positive 12 gives me positive 20. So that's my answer. For number 12, we're still subtracting, and we have to get a least common denominator, but on this problem, I have a bit of a difficulty because my first denominator is not factored. So I have to do an extra step here. So I'm going to start out by factoring x squared minus 64. And they don't have anything in common, so I can't just take something out, but they are both squares, so I can do the difference of squares. So we're going to have x plus 8 and x minus 8, because positive 8 and negative 8 will multiply to give me 64, and the x's will multiply to give me x squared. On the right side, we didn't have to factor anything, so that's good. And now I'm going to determine what my least common multiple is. The process of doing this doesn't necessarily take much out. It just makes it slightly simpler than it would have been before. So for example, this denominator is x plus 8 and x minus 8, and this denominator is x minus 8, so both of them have the x minus 8. So by listing it only once, I am simplifying this slightly, because instead of having 2, we just have 1. And then we also still have to check and see what's left, which is this x plus 8. So my new denominator is x plus 8 and x minus 8. And it doesn't matter what order I put it in. Okay, now what does that do to my numerators? Well, 5x plus 4, the old denominator and the new denominator are the exact same, so 5x plus 4 doesn't have to change at all. For 3, the old denominator was x minus 8. The new denominator has the x minus 8, but it also has x plus 8. So I have to put that in there. Alright, so now I have a denominator that's common, so I can keep that common denominator, and I have to subtract my numerator. So we're going to have a little bit of distribution in this also. So I've got 5x plus 4. I'm going to put the negative with the 3 before I distribute it. So I'm going to have negative 3 times x, and negative 3 times positive 8, which would be negative 24. So the only thing left to do is combine like terms. And there's not too much here. We've got 5x and negative 3x, which is 2x. We've got positive 4 and negative 24, which is negative 20. And then that's going to be my answer. Number 13 you're going to do on your own. Number 14 is a problem we're going to solve, and it's an equation. It has an equals. As long as we have a single fraction equal to a single fraction, we can cross multiply. So for this problem, that means I'm going to have x times x plus 7 equals negative 2 times 3. So simplifying this a little bit, I'm going to multiply the x by the x plus 7, so that's x squared plus 7x equals negative 2 times 3, which is negative 6. And now I've got to figure out how I'm going to solve this. Anytime I have an x squared and an x both together in an equation, I'm going to try to get everything together to one side equal to 0 so that I can factor. So I'm going to add 6 to both sides, which makes my problem be x squared plus 7x plus 6 equals 0. So now I've got 3 terms, and I can factor this. What multiplies to give me 6 and adds to give me 7. So my factors are going to be 6 and 1. If they're both positive, they'll add up to 7. And now I just have to figure out, if these are my factors, what will my solutions be? So remember that your factors and your solutions are opposite. So x plus 6 tells me I have a solution of negative 6, and x plus 1 tells me I have a solution of negative 1. And so these are my solutions. Number 15 you will work on your own. Number 15 on the back page, since there's two 15s, is from 8.2. This is the graphing section. So 8.2 was the first section from this chapter. So we're going to go back and do that now. The first thing I'm going to do with this problem is rewrite it very slightly, which is to put negative 1 out front times 1 over x plus 2. And the only reason I do that is because it helps me to see that I have a negative, which causes my slope to be changed, which causes it to be a reflection. And then I also see that I have x plus 2, and anything in x world is going to be opposite. So instead of shifting right, we're going to shift left 2. And then I also have a plus 1 at the end, which means we're going to shift up 1. Alright, so here's what this does for me. The reflection doesn't do anything just yet. The first thing I have to do is the left, right, up, down. So since this moves left 2 and up 1, my new center point is going to be up here. Now the center point is not part of the actual graph, but it does show me where to put my asymptotes. So left 2 and up 1. What this does is it gives me a brand new center. So I'm going to start from my new center to draw my graph. So from the new center, I have a reflection, and so the slope itself is just negative 1. So from the new center, I'm going to go down 1 over 1 to put my first point. Then I'm going to go back to the center, and I'm going to go up 1, back 1, and so my two dots have to be in opposite quadrants. Okay, so let me fix this. I went right instead of going left. Thankfully I have a little erase here. So left 2 and up 1 would be over here. So here's my asymptotes. And from this center right here, I'm going to do a slope of negative 1, which means I go down 1 over 1 right here, and then go back to the center and go up 1 and back 1 so that my dots are in opposite quadrants. Then I'm going to use the asymptotes to kind of give me a guideline of where to draw towards. So, except I went too far there. So the asymptote shows me what to draw towards, and I have to go through the point. So that's what the graph is going to look like, but we also need to talk about the domain and range. Remember that these things over here, these are the transformations. When it says to describe the transformations, that's what that's for. Alright, so let's do a domain and range. The domain and range is going to be based off of whatever our new center is, and our new center is at negative 2, 1. So when I do the domain, x cannot be negative 2, and when I do the range, y cannot be 1. But in both cases, it will be real numbers otherwise. So we're going to have the real number r, x does not equal negative 2, and the real number r, y does not equal 1. And number 16, you will work on your own. Okay, the last problem I'm going to work is number 17. And we're going to start with this graph, f of x equals 1 over x. And then we're going to add in each of these transformations to get a new equation. So, if we have a reflection, we know that that changes my slope to be negative. So in this case, the slope is currently 1, so we're going to change the slope to be negative 1. We know that we're going to shift 3 units to the right, so inside x world, that's going to be minus 3. And then the 7 units up, that will be after everything else, so at the very end, we'll have plus 7. So my new equation is going to look like this. Negative 1 over x minus 3 plus 7. And if you feel more comfortable putting parentheses around the x minus 3, you can do that. That's just fine. And that's what our equation is going to look like. So number 18 and 19, I want you to try on your own, and then you can check them in class.